All right. So welcome back. Today we're going to be working on solids, liquids, and gases, or the normal states of matter. There's other states of matter such as plasma or the Bose-Einstein condensate, and about 3 or 4 others that they keep discovering, but in really obscure terms. Anyway, so what we need to do is start with our 3 states of matter. So we have solids. Solids. Really? You're going to do this? Solids. We're going to have liquids over here. And we're going to have gases over here. And when something goes from a solid to a liquid, let's say that I have a frozen piece of water and I let it sit out for an hour, it melts. And when I have something going from a liquid to a solid, let's say I have liquid water, and it goes from a liquid to a solid, we call that freezing, which most of you already know. When something goes from a liquid to a gas, let's say that I leave that water on the table for a couple of hours, it evaporates. Evaporation. And when it goes from a gas to a liquid, let's say that it's fall in Minnesota, you're riding the bus or a car, you breathe on the window, and uh, water liquid forms. You draw a little heart and go, "I love you," um, and then your friends poke fun at you and laugh at you. Anyway, so we have that would be condensation. So condensation. And we also have 2 things that you're probably not familiar with. When something goes from a gas to a solid, let's say it's the early fall and it's warm enough to not be raining, but it's cool enough for condensation to start to form, but it freezes on the grass, and the grass is crunchy. It's got white frost on it, whatever. We call that deposition. Something being deposited. Deposition. And then when we've all, well, not all, but most people have played with or seen dry ice. It melts, but it doesn't melt. Why? Well, basically, it's going from a solid to a gas, and we call that sublimation. And with sublimation, you basically have something going from a solid to a gas. It skips the liquid phase. And That brings us to our 3 states of matter again, which we have solids, and a solid basically would be, here's my cube, and there's my cube. There's my solid of something, and the atoms in it are really close together, and they're slow. We'll see. I'm trying to make these really, really close, but anyway, so the atoms are really, really close. And so the atoms are close. And they're cooler. They vibrate slower. And that would be a solid. And that's the reason that we can't put our hands through it. So then we have our liquids. And I'm actually pretty impressed. This is the best I've ever drawn. Um, the atoms are further apart than they are for solids. And they're a little bit, the atoms are a little bit warmer. So the atoms are farther apart. They're a little warmer, and they vibrate more. They vibrate faster. Vibrate faster. And what we're this theory that we're describing the atoms, this is called the atomic molecular theory of matter. It's called the atomic molecular theory of matter. And getting back to our elements. Really, you're going to do that to me? Yeah, this is bizarre. Okay, so and they vibrate faster. So we have our atoms are apart, they're warmer, and they vibrate faster. The atoms are closer together, they're cooler for a solid, and they vibrate slower. And then we have our gas. And the atoms are really far apart from one another. And the atoms are far away. Atoms far apart. They're much warmer. It's supposed to be an H. Much warmer, which gets them vibrating fast. So vibrate fast. So that's your atomic molecular theory of matter, which basically allows us to explain why something is a solid and something is a gas and something is a liquid. Why you can put your hand through a liquid, but you can't put your hand easily through a solid. Why you can put things through, I gotta put this here, whatever, so we're gonna put a gas. Oops, that's supposed to be a line between the two. Gosh. You'd think I couldn't draw. You're right, I can't, because this is a bloody masterpiece compared to what I what I normally draw. That's pretty much it. You guys have the lab. If you have questions, feel free to uh, uh, text me or text message me or email me. For those of you who are not in my class, feel free to leave a comment below and I will respond as quickly as I can. Y'all have a wonderful day and peace.